Last week on the show, so now we're all shelled in. The exterior is well on its way to looking its best, and now we can turn our attention to the mechanicals of this home. Our plumbers are here today to start the rough-in for this house. To get the ball rolling on this bit of work, we need to have them install our lift station.
I'm Steve Nickel from Newfoundland Plumbing Heating. Today we're back. We met with Sheldon and Kayla last weekend and discussed the layout of the house. Now today we're back to do the groundwork on the house. To do groundwork outside of the city in the rural communities, a lot of times you're on a septic sewer system, so typically the septic will come in a bulk grade to meet the septic tank outside. So we need to put in one of these lift stations. This is a Liberty lift pump. It sits down inside the ground, and this is where all our sewer will travel into the lift station, pump up to our drainage, and then out to the septic.
The lift station being our lowest point in the system, Steve and Jimmy will continue to rough in the rest of the underground drainage towards the lift station. Once the guys have all the underground plumbing in place, we're going to go ahead and grade the stone in the basement level. Then we install a 6mm poly over the stone to create a vapor barrier. The plumbers have also roughed in plumbing for a future bathroom, so we install a box around the shower drainage so we know we can access this pipe in the future. Finally, you see Patty applying some acoustic sealant around the perimeter to seal the poly to the walls. Now, it's on to cement. With our pad in place, it really cleans things up. We have a great surface to work off of and keeps all of our trades a little happier. So back with the plumbing to complete the rough-in. The water lines and drainage for upstairs are next.
So today we're going to be going over the kind of piping system that's going to be used at Sheldon and Kayla's. We're going to be using a Aquapex pipe that's most commonly used in residential and some commercial buildings. It can be crimped or expanded for different types of fitting. We are going to use our crimped fitting, which is a copper PEX ring. Just slide it on over the pipe. Slide the fitting into the pipe and use our crimping tool to make the watertight connection. And that's basically all that's to this type of system. Easy enough to run, a lot easier, neater to run than copper. Faster. Only takes one man to run this through a floor joist. This can be used in a couple different joining mechanisms. There's the copper ring. There's also the band ring, which is used with band ring crimpers. You can buy at your local hardware store. This just goes on over the pipe. Same type of system. Fitting goes into the pipe and it just bends this little nipple down and creates the connection. Well, PEX is used mostly in residential and commercial applications. It's used for the water distribution system in the house, and it takes the place of copper, so it actually has more of a insulating factor than copper. It doesn't have to be insulated in a residential application, and it's nice and easy to work with.
Now with the plumbing completed, the electricians can get their stuff in place. Now the electrical is a place where we can't rush the planning. Lots of attention needs to be paid to ensure we have power in place for things like TVs, fireplaces, or even lamps. There's a lot of things to consider when roughing in electrical. The big part is the kitchen. Our cabinet manufacturers actually put together a drawing for the electrician to ensure there's no issues, as there's a lot of lighting in these cabinets as well. After the break, we keep things going on our mechanical rough-ins.
Stop by one of our 3 locations today and get your project started right.
Because of the ever-improving building technology used in residential construction these days, structures become increasingly tighter with regards to air movement. So to help bring fresh air in and stale air out, building codes require us to install a unit to move that air. It's called a HRV.
My name's Adam Rickard. I own a company called Hot Water and Fresh Air Systems. We do a lot of ventilation, installation, service, control wiring, and hot water heating. So the electricians just ran our power for the HRV. I have the ducts in place. Now it's time to put in the core and wire the controls. We have an aluminum core for the best heat transfer possible between the exhaust air and the incoming air. And that just slides in like so. And we have our 2 filters, one for the incoming airstream from outside and one to filter the exhaust air coming from the house. Okay, the last step is to wire our humidity control. I got my wire stripped already. It's a 2-conductor control, 2 extra conductors just in case there's a problem later on. We have extra wire we don't have to run anymore. And I'll just pop that through here. So the signal from the control will tell the unit what to do. We'll run on high speed when there's excess humidity in the indoor air. Otherwise, it will run on continuous low speed. And that just gets plugged in here. We keep our extra conductors bent back so they don't get damaged. Move around and plug in. Now I just have to put the cover on and the HRV is ready to go. But before that, I'm going to do a quick amperage test to make sure the motors are doing what they're supposed to do. And on a startup for an HRV, I just like to test the amps on the motor, make sure it's pulling the right amount of current. This unit runs at 1.4 amps at 110 volts. So let's just do a quick test here. What I'm actually doing in amperage mode, it measures the magnetic field generated by the current flowing through the wire. So here we go. You can see the defrost damper opening there. Turn on to normal speed. Both fans kick in at 1.7. We're at 1.48 amps, 1.44. Full speed down to 0.5. The rated load is 1.4 in high speed, so this unit is good to go.
While Adam finishes up what he needs to get done with regards to our mechanical system in this home, Jeff is going to take care of our septic system outside. If you remember back to the beginning of the season, Jeff dug us some test pits to determine what needed to be done with regards to our septic. Now today, it's time to put that septic system in place.
Classical,
Modern.
contemporary,
With
or without windows?
sand.
Claystone.
Mocha.
It's a girl I got.
Okay. Where's them people with the cue cards that tells me what I'm saying? Bins on Demand is 100% Newfoundland owned and operated. We're a garbage disposal company. We are commercial and residential friendly. We service St. John's and surrounding areas.
The last thing we need to clue up the mechanical portion of this home is the well. Our well driller will drill this well until he acquires the amount of flow desired by the governing bodies. Once he installs the 42 feet of well casing and grouts the casing into the wellbore, he will then continue on with the drilling until he encounters water. water generally runs in seams. Sometimes one seam holds enough water to satisfy the requirements. Other times it takes a series of seams to get the flow that we're looking for. Another point that should be made here is that just because a well is a certain depth, it doesn't mean the well on the adjacent lot will be the same depth. Geology underground is quite unpredictable. For example, the well next door to us is almost 90 feet deeper. With the well in place, Darlene will run the tech cable and water line into the home. Once through the foundation, she's going to work her magic on the pump system.
Basically how it goes, the pump shoots the water up through the hose, in through the hose, in through the tank, and up through the filter and into your house. Power feed will actually start her up. Control box is there to start the pump. Joins it off with this low pressure switch and you have water. Plain and simple.
Now that the last of the mechanical systems are in place, we're going to close it up. Once again this year we're using a blown-in cellulose attic insulation. To prepare for that, we're putting a 6mm poly vapor barrier on the ceiling. Using technical tape and acoustic sealing to complete the install keeps everything airtight. And to help combat the cold, we had Liam stop by to give this home the star treatment with some 2-pound closed cell spray foam. This stuff is magical, really. By expanding into every single crack and crevice, it totally seals the home and prevents air movement within the wall and joist cavities.
Today we're spraying 2-pound closed cell foam, John Mansfield foam here. The process, the foam comes in 2 drums, 2 45-gallon drums, and we have specialised equipment that we pump all our stuff through, and basically it comes out to a spray gun and we spray it onto the walls. We heat it up because it gives us better mixing ratios for our 2 different chemicals that we mix together. Different types of spray foam, yes, there are 2 types of spray foams. We have an open cell and a closed cell. Today we sprayed the closed cell. This here will give us about R6 per inch, so we'll spray about 3.5 inches in the walls here to give us our R21. Open cell foam is more expanding. It'll fill the void, give us about R3 per inch, and both have their different applications, you know, for different reasons. So the open cell is good for soundproofing rooms, interior walls and stuff like that if you're looking for a bit of soundproofing. Closed cell here, this is a vapor barrier, moisture barrier built in, and you get the most R value per inch. The spray foam, well, it gets in every little crack and crevice, kind of deformity at all in your stud. It'll go right up to that versus a bat. A bat is a uniform shape, and if there's any little places missed or anything like that, you're going to lose your R value or you'll get air leakages. versus the spray foam is going to fill everything, and you'll get a more uniformed product right across your cavities.
Liam does multiple passes over the same area to build the foam to its desired thickness. So let's talk about the reasons we love spray foam. The first thing I really like is that it gives the exterior walls more strength. The spray foam acts like a glue, bonding sheeting and studs together. Next is the fact that this product is an insulation and vapor barrier in one. No need to spend countless hours covering the insulation with plastic. The third thing is that there's very little waste. A couple of garbage bags of overspray is about it. But the very last thing is the time. It's a very quick process. Liam is in and out, which means we can move on to the next phase even quicker. Speaking of which, next week on the show,